Today we will be learning about the concept heights and distances. As we have done with our trigonometry, this is a continuation chapter to that. In this chapter, we will be knowing the practical use of trigonometry in determining height of objects or angle of objects. So using this trigonometry, we will be finding height of various kinds of objects and breadth of objects and the distance from one point to other point using angles. Right. In this chapter, we will be having three main concepts, which is first one is line of sight, second one is angle of elevation, and the third one is angle of depression. These are the three concepts what we are going to discuss in this chapter. Let's learn the definitions of these three chapters one after the other. First, here we have a line of sight. So to understand this, first consider a tower and a horizontal ground level, and this is a tower, and consider here one person is standing at this level. Here consider these 3 points A, B and C. And whenever we want to see any object which is placed at higher level to our eye level, how we'll be using, how we'll be seeing like this. Now in this way we'll be seeing an object or any kind of tower, building, tree, whatever it may be. So in this direction we'll be seeing an pin, object or whatever which is placed. And if we observe here we have a path, right? Whatever the path we are getting or we are using to see one object which is placed at any other eye level, this path is called as a line of sight. This imaginary line is called as a line of sight. And here in this case, the person is looking at the object which is placed at above his eye level. Above his eye level, right? So he is looking upwards when compared to his eye level. The angle whatever we are getting in this case is called as an angle of elevation. The angle which is formed to see one object which is placed at above our eye level is called as an angle of elevation. Why we'll call it as an angle of elevation? In general terms, we'll be using this word to elevate someone or to make someone high, right? So in this case also we are lifting our head or lifting our eyes to see an object which is placed at above our eye level, right? So that is why we'll call it as an angle of elevation. Now, to understand the next concept, just make the positions reverse. Consider a person is standing at A level and he is looking at an object which is placed at sea level, right? So in this case, how will we see an object which is placed at a lower level to our eyesight? So definitely we'll bend our head and our line of sight will be changed in one direction to other direction. So in initial case, the angle of elevation will be upwards. Whereas in the second case, we are looking downwards, right? So our way will be reverse. In downwards, we are using. So here also we will be having this. We know always we have to count these angles using a perpendicular line and a horizontal line. So here also we will be having one horizontal line, no imaginary horizontal line. And the angle formed between this imaginary horizontal line and the line of sight is called as an angle of depression. Angle of depression. So what is the general meaning of this depression? So whenever we feel low, that means we'll be saying it as depressed or depression. No. So in this case also we are seeing an object which is placed at lower our eye level. So that is why we'll call it as an angle of depression. And definitely here also we'll be having one point. In this case, this angle of elevation and the angle of depression remain same. Just the positions are changing and the way of seeing is changing. The angle of elevation and the angle of depression remain same. That is angle DAC C is equals to angle BCE, because these two are parallel lines and AC is a transversal, and we know these two angles are alternate angles. So angle of elevation is equals to the angle of depression in this case. Here we have our question number 1 from our exercise chapter 23. The angle of elevation of a top of a pole from a point on the level ground and 50 meters away from the pole is 30 degrees. So find the height of the pole. So first try to understand the question. Here we have an angle of elevation of the top of the pole. First draw a pole AB from a point on the level ground. So here we are having a point on the level ground which is 15 meters away. Let this be our C with a pole of angle 30 degrees. Angle of elevation is 30 degrees. Here we need to find the height of the pole. So let the height of the pole be h. So first write, let AB is the pole with height h and C is the point that we know with the distance of 15 meters. Here we need to find our height of the pole, which is h. Right? Let height is equals to h. Right? So here we are having this base and the perpendicular, and definitely we'll know this is a 90-degree angle, which is a right angle, and here the two sides which are included are the base side and the perpendicular side. What is the trigonometric function which includes this base side as well as the perpendicular side? So we can go with tan and cot here. We know that tan theta is equals to perpendicular by base, whereas theta value is given, which is 30, that is tan 30 is equals to, what is a perpendicular, which is h, that is what we need to find h, and the base value is given, which is 15 meters. What is the value of tan 30, which is 1 by root 3 is equals to h by 15 meters. Now let's transpose this 15 here. We'll get 15 by root 3 is equals to h, and we know that 15 can be written as 5 into 3 by root 3. This 3 can be written as 5 into root 3 into root 3 by root 3. This gets cancelled. Here we'll be having 5 root 3 meters. So if you want, we can simplify our answer like this, or else we can substitute this root 3 value as 5 into 1.732 meters, which is nothing but 8.66 meters. So our height of this pole is AB. So in this, mostly we'll be using, most of the times we'll be using tan function, because here we'll be finding the height of the objects at different positions with different distance and different angles. Either it may be angle of elevation or angle of depression. Most of the cases we'll be using trigonometric. In trigonometric functions we'll be using tangent. Next, question number 2. Here we have cliff and buoy, which is an angle of depression is 30 degrees. We need to find the distance between the buoy and the foot of the cliff. So first, here we'll be having a cliff, whereas the height of this cliff is 50 meters. So here it is given as 50 meters. Let's take it as A and B. So here AB is the cliff, and here AB is equals to 50 meters. This is what they have given. And here we have an angle of depression of a buoy, which is an angle. So somewhere it is having with an angle of depression. So angle of depression will be like this. So, and we know angle of depression, angle of elevation will be equal in this cases. So, here the angle of depression will be equals to 30 degrees. Let this be our point C. So, here C is y, and here we know, we don't know this distance. Let this be A meters. So, BC is equals to A meters. And here we have angle of depression. So, what is the angle of depression here? Angle ACB is equals to 30 degrees. Angle ACB is 30 degrees. And here we need to find the base. Perpendicular is given, we need to find the base. So, the trigonometric function which includes these two sides is tangent, which is equals to perpendicular by base, right? So, and here we have given our theta value, which is tan 30, which is equal to perpendicular is 50 meters, and we have considered our base as A, and we know our tan 30 is 1 by root 3, which is equals to 50 meter by A. So we need to find our A value, which is A is equals to 50 into root 3 meters, and here we have given our root 3 values, which is A is equals to 50 into 1.732, which is equals to 86.6 meters. So here the distance from foot of the cliff to the boy is 86.6 meters.